Hello friends, and now in section number 8 let's talk about differentiation of exponential functions. And so these are functions of this format here, y, the functions of the form y equal to exponent fx, where fx is a function of x. And then so in general we are going to be using chain rule differentiate exponential functions. And then so let's have a look at an example. Assume we have a function y equal to exponent to x like that. And then so let's begin, let's try to differentiate this. Then we shall have, so we have y equal to exponent to x, but then now this fx, let's say that let u equal to 2x, and then when we introduce in another variable, so we can now here use chain rule, and then we know that from chain rule we have dy dx being equal to dy du times du dx, or like that. And then so our dy dx is going to equal to our dy du, but then so what is our dy du? We shall get it from here that y equal to exponent, and the fx has been named, or it has been changed to a variable u. And then so now the first point to note here it is that whenever you differentiate, let's say whenever you differentiate an exponential function, like here having a variable u, d by du of exponent u, this one it is the same as the very function exponent u. And so this is a very important, this is a very important property to be knowing. So you must be knowing this, that whenever you differentiate with respect to this variable, and then the function at the top here, or the power here at the top, it is the very one with which you're differentiating with respect to, it will give you the very function which is exponent u. And then so let's try to work out this. So we have y equal to exponent u, and then so what is dy du from that case? We can have dy du being equal to d with respect to du, or differentiating exponent u with respect to du, which will remain the same as exponent u. And then so having gotten our dy du, let's try to get du dx, but then we know that u is equal to 2x, and then du dx is going to equal to a 2, and then so we shall substitute into our formula for chain rule, which is dy dx equal to dy du, and dy du is exponent u times a 2, which is du dx. So here I shall have 2 exponent u, which is the same as 2 exponent to x. And then after looking at that, let's have a look at another example here. So assuming we have also another exponential function, which is y equal to exponent x squared, all right, like that. And so in the same, using the same steps like in the previous example, you can say that we let u equal to our fx, which is x squared, and then so we shall have our y equal to exponent u. So using chain rule, we know that dy dx is equal to dy du, but then dy dt is the same, it will be the same because we are differentiating the exponent u with respect to u, so it will remain the same exponent u times du dx. But then from this we can get the du dx. The du dx here, it will be 2x. You only have to drop the power and then subtract 1 from the previous power. So we shall have exponent u times 2x, and then our dy dx will be 2x exponent u, but then we know that a u is x squared in this case. We shall have 2x exponent x squared. All right, so and then that is also the derivative function for the given function y equal to exponent x squared. And then so let's have a look at an example involving a trigonometric function. So assuming, let's first draw a general formula from this. So I happen to find that this fx, it is the derivative of x squared. So you can say that given a function y equal to exponent of fx, and then so the dy dx will always be the derivative of the fx exponent fx. And then so hope even the first example can illustrate that. We had the derivative of 2x, which was a 2, and then exponent 2x, which was a given function. So even this other one, we had the fx being x squared, and then its derivative is 2x, then exponent x squared. So from that you can draw that it is f derivative of x exponent fx. So now let's try to look at another example here. Show me have our function y being equal to exponent x cos x. Now in this case, you happen to find that exponent x it is a product, or it is forming a product with cos x. And then so how do we differentiate this? Now when you're differentiating this, we shall have to use product rule because this is a product of two functions. And then so we shall say that dy dx is going to equal to, remember from product rule we have dy dx being equal to v du dx plus u dv dx, like that. And then so taking this to be my u, and then this one here to be my v, we shall have v, which is cos x, and then du dx, remember my u, it is exponent x, so d by dx of ex, this is the du dx, it is the same as ex, so cos x times exponent x plus, then if this is v du dx plus u, which is exponent x, then dv dx, and then we know that when you differentiate a cos x, we shall get a negative sine x, like that. So let's proceed. We shall have our dy dx being equal to exponent x cos x minus exponent x sine x. So we can factorize out the exponent x, and then we finally get our dy dx being equal to exponent x into cos x minus sine x. And then this is our derivative function for this function ex cosine, for our given function exponent x, ex cos x. Let me try to remove this. Then that is our derivative function. And then so we can have also some trial questions. And then so this one here, it is a product involving an exponential function. And so you can try out this as a trial question. Let me leave this as a trial question. So we can have these are our trial questions. We can have y, or differentiate y equal to exponent of x squared plus 1, right, like that. And then we can also have y equal to exponent x sine 2x. And we can also have y equal to exponent x exponent negative x, like that. And so from this one here, now you can use the general formula that the derivative of the fx, which is 2x. So now this one, by mere looking at it, you can tell that the derivative of this function here, it will be 2x exponent x squared plus 1. So it is just, in the derivative, we have the derivative of the fx multiplying the given function, and that is the derivative of the given function. So from that, I think we can proceed to the next section, and then that is differentiation of logarithmic functions. So this is all about exponential functions. That's how we differentiate them. When you have it in a quotient, you use quotient rule. When you have it in a product, you use product rule, just like in this case here.